So essentially we finished off the demand side of the economy and we were starting the discussion on the supply side of the economy. Thank you for those recaps. In talking about the supply side of the economy, what we were saying was that the factors that determine output, or the factors that determine supply, are, as a recap, technology, capital, labor, and other resources that we might input into that function. But of those, the most important is labor. So what we say is that the aggregate supply curve is determined essentially by the labor market. So in all our discussions, we assume that capital is fixed. In assuming that capital is fixed, one thing which you might sort of struggle with is the idea that we do have investment spending, and investment spending is spending towards capital. So if we're spending on investment, why is capital fixed? So it's just a question of what time frame are we looking at. In other words, you can spend a lot of money on investment this year building a factory, but it doesn't mean that the factory is necessarily ready this year. If you're going to take 5 years to build a factory, or like if Eskom is going to build a power plant, it takes 5 years to build a power plant. It doesn't mean that they spend all that money in 1 year. They spend money over 5 years building a plant, right? So we can have investment spending even though capital is staying fixed for now. Yeah? So capital is fixed. Our labor, however, can vary quite easily. So we have an upward sloping aggregate supply curve. How do we get to this upward sloping aggregate supply curve? So we saw previously, or maybe I should just bring those equations back again. We said if we have a very simple production function such that y equals n, okay, and n just means the number of people employed. Okay? In other words, if you took the whole workable labor supply, in other words, what we call the workforce, right? So if you had the whole workforce, we call the whole workforce L. We can divide the entire workforce L into the unemployed people and the employed people. N is the number of people employed. U would be the number of people unemployed. Right? So output then is simply equal to the number of people employed. So each person that you employ can produce 1 unit of output. There is no diminishing marginal returns. Okay? That was our production function. Then we said, right, if we have a wage setting relation or equation, set to our labor supply equation, what we say is, and someone just needed clarification on this previously, this entire term here is the real wage. In other words, W is the nominal wage. When we adjust W, the nominal wage, from the price level, then we have the real wage. Okay? So W over P is the real wage. The real wage then is a function of unemployment and some other factors which we're not really that interested in. So Z is the factors that would increase the wage that people would want, and U, the number of people unemployed, right, decreases the wage that you want. In other words, the more people are unemployed, the less likely you are to get a good wage. Or let's say the less likely you are going to be able to negotiate a high wage if there are lots of people unemployed. Because then, your employer can say, well, you're asking for a wage that's too high, so I'm just going to employ someone else. Right? So the more people are unemployed, the lower your wage is likely to be, hence the negative relation. Z, the positive, just says anything that makes your wage potentially higher. Yeah.
What effect will the minimum wage have on that?
So minimum wage, so the discussion here assumes no market distortion. What effect would a minimum wage have on a labor market if we are talking more generally in microeconomic terms, right, and we have a labor market, I'm not sure if I have. We can come back to that question. I want to get to a good diagram that we can use to answer that question. Otherwise, it's going to be a little bit difficult to talk about. Okay. So that was the wage setting relation. Sorry. Then we also have the price setting. So the wage setting relation, that's labor supply. That's people and the wages that they want to work for, right? So in other words, Z could be something like your education. No, Z's not your education. No, yeah, something like education. You can think of Z as being something like that. That would enable you to get a higher wage. Okay. Then the price setting equation, so that this is from the labor demand side, this is from the firm. The real wage that the firm sets, we said, is linked to the output that someone produces. So the number 1 there simply means that each laborer produces 1 unit of output. The more output each person produces, the higher that number at the numerator would be. But then what we do is we take whatever it is that gets produced and we're dividing it by, and this is the point, the idea that the firm isn't going to pay necessarily all of its profits over to the worker. And the more profits it wants to retain, the less real wage it's prepared to pay the workers. So if we call this little Greek letter mu the profit that the firm wants to hold on to, then what we need to do is adjust whatever it is that is being produced, the value of production, and we adjust it for the profits that the firm wants to take. So the higher the profits that the firm wants, the lower the real wage the firm is prepared to pay. So 1 essentially here is a measure of productivity. The higher the productivity of labor, the higher the wage. The higher the profits that the firm wants to hold on to, the lower the wage. Okay. So if we then look at those equations and we say, if y is equal to n, so n is the number of people employed, and we know that u is the unemployment rate, then, so it says from equations 1 and 4, let me just show you exactly what that means. So we call this one equation 1, y equals n, and this one equation 4. Unemployment is simply 1 minus, the unemployment rate is simply the total amount of the labor force minus the number of people employed, right? So if the number of people employed is equal to y, then if we combine equations 4 and 1, we get that the unemployment rate is equal to 1 minus the number of people employed divided by L, and the number of people employed is represented by y, so it's just y over L. Okay? You got that? Then again, from taking those equations up at the top there, so 2 and 3, so this was equation 2, your wage setting relation, and then your price setting relation from the firms. Take those two, we combine them, and we get that the price level is equal to the expected price level times 1 plus mu times whatever the function u and z is. In other words, the price level today is positively related to expected price level, it's positively related to the profits that the firm wants to earn. It is negatively related to the unemployment rate, and it's positively related to some other factors that we're not really sure of. Well, they're just not very important for us right now. If we then call this equation here equation 6, and we call this equation equation 7, and we combine those two equations, we end up with this equation here. Okay? So what have we got? Let's just talk about it a little bit. Oh, sorry. That's not where I thought it was going to go. What is it telling us? So there's a little write-up that Blanchard has with this diagram. So we're going to read through it and just work through it as well. The price level P depends on the expected price level, PE, the level of output, Y, mu, which is to say the profits that the firms want to retain, as well as something else just called Z, which is everything else apart from the labor force. The first property, in other words, he refers to this as the aggregate supply relation. Why is this an aggregate supply relation? Let's look at this equation. Remember, this term here represents unemployment, right? The higher the level of unemployment, the lower the price level, is what we discovered, yeah? But the higher the level of unemployment means the lower the level of output, okay? In other words, the lower the level of output, right, the higher the price level. Does that make sense? Sorry, the lower the level of output, the lower the price level. You got that? Okay. So as employment increases, in other words, as N increases, Y increases. As Y increases, although there's a negative sign here, it's counterbalanced by the fact that this whole term is negative, so it's negative with a negative, if that makes sense. In other words, as Y increases, this negative and this negative cancel each other out, so you have a positive. As Y increases, price increases. Right? So what we have is a relationship. This entire equation, remember, is derived from the labor market. The labor market is telling us as the number of people get employed increases, so output increases, and as output increases, the price level increases. We have a positive sloping aggregate supply curve. It's telling us as we increase the number of people employed and we increase output, as we increase production, the relationship between prices and production is such that increase in production causes an increase in prices. Okay? So it's upward sloping. So what does our little write-up here tell us? Let me just zoom in a bit more. An increase in output leads to an increase in employment. The increase in employment leads to a decrease in unemployment, therefore a decrease in the unemployment ratio. The lower unemployment rate leads to an increase in the nominal wage. The increase in the nominal wage leads to an increase in the prices set by firms, and therefore to an increase in price in general. Right? So that is the nature of the relationship there. Increase in the number of people employed pushes up the wage rate. Pushing up the wage rate means that the firms now require higher prices in order to supply more. And so you have a positive relationship. There's more to that equation though, because we've also got, as it says here, additionally, if there's an increase in the expected price level, what happens? If wage setters expect the price level to be higher, then we get higher nominal wage demands, and the increase in nominal wage demands leads to increased costs, which leads to higher prices as well. Yeah, in other words, if we're looking at our equation, we're also saying that an increase in expected price level leads to an increase in the price level. Now, we happy with that idea? The way that we will see this happens is an increase in the expected price level shifts the aggregate supply curve to the left, which causes an increase in prices. Now, similar to the microeconomic mechanism, because we are dealing with the labor market, but it's a little bit more involved. So, where are we? I'm not sure why this thing is not giving the full picture, but okay. So, potential output then, we spoke about this previously, is associated with full employment. What does that mean? Yeah. Yeah. No. Only a change in the actual price level is a movement along aggregate supply. Okay. In other words, when we are plotting, let's just be clear on this. When we're plotting this relationship, we're plotting y against p. So the only thing that causes a movement along here is a change in y and a change in p. Okay? Those are the only things that are movements. So when we look at this equation, the only things that are movements in that equation are change in this factor here and change in this factor here. Change any of these other things and you're shifting it because it's not directly one of these two components. So if this is our labor market, no, actually I want to come back to, let me come back to this later. I feel like this is, let's first talk about here. I'm not sure how we skip this, but anyway. Okay. So equilibrium in our labor market, what is going on? Let's get back here. So that's our labor market. What happens? If we've got these two equations, if we've got the price setting equation and the wage setting equation in terms of Blanchard, we know if we plot the real wage against the unemployment rate, we have that the price setting equation is just simply a perfectly elastic flat curve. In other words, the real wage rate in terms of the price setting relationship is not affected by the unemployment rate. Hence it's just a perfectly elastic curve. Whereas the wage setting relation from the laborer's side is downward sloping. In other words, as the unemployment rate increases, so the wage that people are willing to accept is going to be decreasing. If we then invert this, and instead of plotting the unemployment rate, we plot the employment rate, what do we have? As the employment rate increases, so the wage that we accept increases. And so we have an upward sloping labor supply curve. Okay? We have an upward sloping labor supply curve if we are plotting laboring employed versus real wage. But in terms of the price setting equation, we have a perfectly elastic labor demand curve. Why is it perfectly flat? Why is it perfectly elastic? Because remember our production function y equals n says there's no diminishing marginal returns. Right? In other words, the productivity of each laborer is exactly constant. So this here, this number 1 is constant. Right? If we had diminishing marginal returns, how would we adjust that intercept term over there? Well, what would happen is as we increase n, if we've got diminishing marginal returns, what happens to the output that those laborers produce? It increases, but it increases at a slower rate, right? So if it's increasing at a smaller rate, it means that the average productivity of each laborer is therefore decreasing. The average output of each laborer is decreasing. If the average output of each laborer is decreasing, then what we're saying is as n increases, what would happen to this number up here, that productivity number? It would be decreasing. If it was decreasing, what does that tell you about the price setting relationship? What would that tell you about the real wage that firms would be willing to pay? If as the firm employs more people, those people are on average less productive, what are they willing to pay? Less, right? In other words, if this number was not constant number 1, this number here, 1, we would have a downward sloping labor demand curve. Yeah? Can you see why in this instance the labor demand curve is not downward sloping? Okay. But, so that's just Blanchard's, the way Blanchard sets it up, but having spoken about now the aggregate supply curve and understanding these equations, when we now look at a more general labor market, what we would normally deal with is a downward sloping labor demand curve. So this diagram here that you see now is the same as Blanchard's diagram, in the sense that we have a labor demand and a labor supply, right? The labor supply is upward sloping as we increase employment, so the wage that people are willing to accept increases, right? Whereas in Blanchard, he has a perfectly flat elastic labor demand curve. We now have a downward sloping labor demand curve. The only difference between this labor demand curve and Blanchard's labor demand curve is Blanchard does not assume diminishing marginal returns. His production function is simply y equals n. If we were to have diminishing marginal returns, you'd have a function like y equals n to the half, something like that. Oh no, wait, n to the half, would that work? Yeah. Okay, n to the half, in other words, would give you increasing at a decreasing rate. Someone who's maths, you can double check me on that. Does n to the half give you a decreasing rate? I think it does. Okay. Oh, sorry. One last thing there. So now that we have this labor market, this point of equilibrium, where labor demand and labor supply intersect, is what we would call full employment. So, to answer your question, how does the minimum wage affect this?
Will it have like a flat line up
Yeah.
until, well, at the price if the minimum wage is at
Yes.
the
So if it was a binding minimum wage, the minimum wage was set above the market clearing wage rates, right? That would then affect the quantity of people employed. It would affect the output level. It would affect the price level as well, because it would influence the wage. This diagram, everyone happy? Okay. So what then is aggregate supply? Aggregate supply is the relationship between the quantity of output supplied and the price level. Aggregate supply curve shows the amount of output that firms are willing and able to supply at each price level. And we can see that that is influenced by the price of the resources that go into the production function. In our particular instance, the resource that we're interested in is labor. So as the price of labor changes, so the cost of production change. As the cost of production change, so firms require different prices. So what causes a shift in the aggregate supply curve? Any factor that affects production. In other words, changes in productivity, changes in technology, changes in legal institutional environment, changes in expectations. So how does that happen? So this is to answer your question, right? Changes in expectations with prices, shifts that aggregate supply curve. What I want you to do now is do a work activity. Okay? So you're going to ultimately derive an aggregate supply curve. You're going to derive an aggregate supply curve from a labor market. Okay? So you draw a labor market, change the price level. How does that affect the labor market? How does that affect the level of output? And how do we therefore derive an aggregate supply curve? Okay? Having done that, I want to know what does a change in productivity do? How does that affect the aggregate supply curve? So if you want to, you can just use Blanchard's labor market with a perfectly elastic demand curve, or you can use a downward sloping demand curve. It's not that important. Either way. Okay? So draw a labor market from your labor market, derive an aggregate supply curve, then change productivity, and then tell me what happens to the aggregate supply curve. Working groups.